So in terms of the bigger picture and what is SNOMED CT? SNOMED CT is a clinical terminology, and in fact it's one of the most comprehensive clinical terminologies in the world. It supports multilingual use across different languages, and there is unlimited variation as to what you can use it as. It supports effective recording, retrieval, analysis of high quality clinical data in health records. SNOMED CT also makes health record meaningful. And what we mean by that is that SNOMED captures the meaning of clinical concepts in a formal way that enables analysis, decision support, and other queries to be performed by a computer. It's designed based on clinical requirements and decades of experience, mostly in United States and United Kingdom, as well as around the world. It's quality assured and updated regularly to meet new and changing medical knowledge. It's also customizable using extensions, subsets, mappings, and language preferences. It maps to a range of other international standards, including ICD-10, OPCS-4, GMDN, and ICPC-2. And it's being used in more than 80 countries around the world. So what are the key benefits that you get from using SNOMED CT? Firstly, when you get benefit leveraging as well established global terminology, it's a solid foundation for representing the information that you need to capture in your clinical records. SNOMED CT also allows you to improve access to relevant clinical guidelines and decision support, which can lead to better health outcomes and reduction of costs. SNOMED also provides a so-called common language that supports data interoperability for exchanging health records and linking to clinical knowledge resources. And SNOMED CT also enables improved clinical and business intelligence, which can support better planning and delivery of healthcare services. SNOMED covers a broad range of clinical content. It contains more than just diseases and procedures. So here you can see SNOMED's main content areas. They include body structures such as anatomical body systems, clinical findings that includes diseases, symptoms, signs, and test results, environments and geographical locations that include different countries, regions, and so on. Observable entities that include tests and measurements like height, weight, and body pressure, and organisms such as plants, animals, and microorganisms, including bacteria and viruses like COVID. And pharmaceutical biological products that include drug products, vitamins, hormones, and so on. Procedures are also covered that include surgical procedures, laboratory, radiology, and other therapies. Specimens include blood, urine, and biopsy specimens, and substances include chemical substances, food substances, and others. As you can see, there are many other content areas as well. So SNOMED CT has a broad scope of clinical content that can be used to record a wide range of clinical data in an electronic health record, from recording a patient's symptom, diagnoses, procedures, and medical history to recording their social circumstances, test results, medications, therapy, and follow-up. And for each of data recorded in health records, the clinician can record it at whatever level they like of detail that is required for clinical use. For example, clinician could record a myocardial infarction, or they may choose to be more specific and record an acute myocardial infarction due to right coronary artery occlusion. It may depend on what stage in the clinical journey the patient is at. Once recorded, the data at that detailed level, the data can then be queried and grouped at a more abstract level, such as the heart disease. SNOMED is not just a set of codes. It also provides logical relationships between concepts, which defines the meaning of these concepts and supports meaning-based query and processing of the data. This means that computer systems can process SNOMED encoded health records. At the same time, SNOMED also enables human readable terms in different languages and dialects to be linked to each concept. So SNOMED's design is based on three main types of components: concepts, descriptions, relationships. And so let's have a closer look at these. Firstly, a concept is a clinical idea that has a unique meaning and a unique identifier. Here we have a doctor who is thinking about a clinical idea, and he's thinking how to represent it. So there are, for example, imagine a clinical idea, which is a necrosis of the heart, commonly known as a heart attack or myocardial infarction. In SNOMED, myocardial infarction is a representation of a code that is 22298-006. But each concept then has two or more descriptions, which are the human readable terms associated with a clinical idea. There is always a fully specified name. In this case, it's myocardial infarction disorder, which unambiguously represents the meaning of the concept. And then there is one or more synonyms such as heart attack, or there could be other synonyms that are used. These are alternative ways of referring to the same clinical meaning. And each description also has a unique identifier. Once the synonyms have been created, then we use something called a language reference set to select which of these descriptions are preferred and acceptable in a particular country, region, or clinical setting. This allows us to customize the way in which we refer to each clinical concept. So here you can see how it is represented in terms of different synonyms that can be used. The third type of component is the relationship. A relationship is basically a set of three concepts: the source concept, the destination concept, and the attribute or relationship type. Relationships which use the ISA attribute form the hierarchy in SNOMED CT and allow each concept to have a multiple parents. For example, a myocardial infarction has four ISA relationships, which say that it is a ischemic heart disease, it is a myocardial disease, it is a myocardial necrosis, and it is a necrosis of anatomical site. So here you can see how it would be represented in SNOMED. SNOMED CT can be thought of like a tree with branches, but this is a upside down tree because the root concept is actually at the top and the leaf concept is at the bottom. The root concept is the most general concept in SNOMED CT. It's called SNOMED CT concept. And everything else in SNOMED is a type of SNOMED CT concept. Directly under the root concept are the top level hierarchies, such as clinical finding, procedure, organism. And then as you can go down the hierarchy, you can get more and more specific. In this case, we have a finding site, then cardiovascular finding, cardiac site, and so on. The other analogy we use when talking about SNOMED CT is that it is like a family tree. If we focus on one particular concept, in this case, we'll focus on myocardial infarction, and then we call the concept immediately above in the hierarchy, the parents. So myocardial disease is one of the parents of myocardial infarction. And we call the concepts immediately below it in the hierarchy, the children. So acute myocardial infarction is one of the children. If we look at all of the concepts in the hierarchy above our concept, we call them ancestors or subtype of myocardial infarction. And all the concepts below our concept are called the descendants or subtype of myocardial infarction. In addition to the ISA relationships which form the hierarchy of SNOMED, we also have relationships that specifically, or rather specify different defining characteristics of the concepts. For example, a myocardial infarction has a finding site of myocardium structure and an associated morphology of infarct. These are called attribute relationships because they use different attributes. SNOMED CT has, SNOMED CT has hundreds of thousands of these defining relationships, which connect concepts together. So to ensure that these relationships are defined consistently, so they can be queried consistently, SNOMED has a concept model. The concept model specifies the rules for how SNOMED content can be defined, including the domain, range, and cardinality of each attribute. For example, the domain of the finding site attribute is all the clinical findings, and the range is the set of anatomical or acquired body structures. So this relationship, fracture of bone has finding site bone structure, is concept model valid because the source concept, fracture of bone, is a type of clinical finding and is therefore in the valid domain of the attribute, and the destination concept bone structure is a type of anatomical structure, so it's in the valid range of the attribute. SNOMED also has a machine readable version of the concept model called the MRCM, which is distributed along with the international release. Another important feature of SNOMED CT is that its formal logic is based on description logic, and this enables automated inferences. For example, in this case, a description of logic classifier can infer that a fracture of femur is a type of fracture of lower limb, which is a type of fracture of bone based on the defining relationships of each of these concepts. SNOMED International provides a SNOMED CT browser that lets you browse the SNOMED CT International Edition and a number of national editions as well. So you can find this at browser.snomedtools.org. Access is open to anybody in the world, and you can view SNOMED CT content. In the browser, you can view each of the concept definitions as a diagram, and it looks like this. You can also access the machine readable concept model by clicking on the MRCM link on the browser homepage, as is shown here. So additional consideration for us to cover is what is the difference between the clinical terminology and classification, and how both of these are used for different purposes. So classifications such as ICD-10 are typically used to summarize data for statistical reporting. They group diseases together into specific categories in a way that avoids cases being counted twice. So by design, each code belongs to a single category. So in order to ensure consistent coding of each disease, the coding process is performed based on established coding rules. In contrast, clinical terminologies like SNOMED CT are designed to support clinicians at the point of care. The data can be recorded at a more detailed level and then grouped up into multiple different categories, depending on the use case. The computable definitions provided by the ontology then enable point of care queries, population analytics, and clinical research. And the terminology can also provide the clinical terms used by clinicians. So let's consider an example of viral pneumonia and look at how a classification and a clinical terminology differ in their support for data uses. Firstly, we'll use ICD-10 and we'll code viral pneumonia as J12. This is the ICD-10 code for viral pneumonia. Here are the different chapters of ICD, and if you are unfamiliar with ICD-10, you may not initially know exactly which chapter to find viral pneumonia in. Is it in chapter 1, which is for certain infectious and parasitic diseases, or is it in chapter 10, which is for diseases of the respiratory system? Now, viral pneumonia can be described as both an infectious disease and it also is a respiratory disease. So in theory, it could be in both chapters, but we know that in a classification, it can only exist in one of these chapters, because in a classification, codes can only be grouped into a single category. If we look inside chapter 10, which has the disease of the respiratory system, we see that this chapter contains the codes that start with the letter J. And in particular, we can find the code J12 for viral pneumonia, not elsewhere classified. So let's come back to our patient who has viral pneumonia and see what types of questions we can answer with ICD-10. So firstly, does the patient have a respiratory disorder? Well, in ICD-10, if a code appears in a chapter J, this means that the code refers to a respiratory condition. So the answer is yes. But does the patient have an infection? Well, we know that viral pneumonia is caused by a virus, which makes it an infectious disease, but there's nothing about the code J12 that tells us this. So we can only assume that the answer is no. Does the disorder affect the lungs? Well, pneumonia does affect the lungs, but as with the last query, the code J12 doesn't tell you about which body side it affects, so we don't know that. And lastly, is the disorder caused by virus? Well, obviously, viral pneumonia is caused by virus, but there are no relationships in ICD-10 that can help you answer this question. So now let's code this patient's diagnosis using the SNOMED CT code for viral pneumonia, which is, by the way, 7557004. SNOMED codes are typically not displayed on the user interface because they don't include any clinically relevant information. In this case, we've included it here as a part of the discussion only. But if we explore how the SNOMED CT concept for viral pneumonia is defined in SNOMED CT, we can go to the SNOMED CT browser and look up the concept with this ID. We can see that this concept has two parent concepts, which say that this disorder is both a type of infective pneumonia, which itself is a type of infectious disease, and also is a type of viral lower respiratory infection, which is a type of respiratory disease. And if we look at the additional defining characteristics for this concept, we can see that viral pneumonia has a pathological process of infectious process. It has an associated morphology of inflammation and consolidation. It has a finding site of lung structure, and it has a causative agent of virus. These defining characteristics are explicitly stated in SNOMED CT, which enables detailed inferences to be performed. So now let's consider the same set of questions, but this time we'll use the SNOMED CT concept for viral pneumonia. So firstly, does the patient have a respiratory disorder? Yes, because viral pneumonia is a subtype of respiratory disease. Does the patient have an infection? The answer is yes, because viral pneumonia is also a subtype of infectious disease. Does the disorder affect the lung? Yes, in SNOMED CT, viral pneumonia is defined with a finding site of lung structures. And is the disorder caused by a virus? The answer is yes, because in SNOMED CT, viral pneumonia is modeled with a causative agent of virus. In summary, SNOMED CT is able to answer these meaning-based questions because of the way it has been designed. And if you go to SNOMED International website at snomed.org and look at the SNOMED CT menu, you can see different education opportunities to learn about these concepts and other topics that would be of potential interest to you. Since this introductory level presentation may not cover all the areas that may be of relevance. I would also like to mention that we have courses now that Thailand is part of the member country list. It is available free of charge for any user in Thailand. And here are some of the courses that are available and more. And lastly, we have a SNOMED CT document library at snomed.org/doc, which includes a range of guides, specifications, presentations, and a SNOMED CT glossary. It's absolutely free of charge for anybody anywhere in the world. So please feel free to explore these resources as you may find them useful.